Hi everybody and welcome. Today we're going to be taking a look at finishing up our notes on factoring polynomials with really large power degrees in the first term. So yesterday we talked about the factor theorem and the irrational zeros theorem. Today we're going to finish up with some more practice applying these and seeing the contexts in which they come up. So really what we're focusing in on is zeros of our functions, and by zeros we're specifically referring to x-intercepts where we cross the x-axis or touch the x-axis. So hopefully after watching today's video you will feel confident and be able to complete practice questions relating to factoring polynomials. So review of the factor theorem. This is just a quick reminder from yesterday, and what we were saying yesterday was that for our factor theorem, if we divide and the remainder equals 0, then what we divided by is a factor. For our second theorem here, our rational zeros theorem, we had a few steps, and I'll just remind you of those steps. That way, if you don't have access to yesterday's notes, you'll be able to refer back to these here. So step 1, break first and last term into their factors. Step 2, we divide last term over first term factors. And then step 3, we guess and check until we find the remainder equals 0. And then step 4, it's a factor if remainder equals 0. So really the first two terms are where a majority of the work comes in. And again, like I said, this is where factoring, breaking them down, dividing them, those are basically the steps that we are looking into here. So for today, we're just going to be filling in some more notes that take us on to the next step of how we use these things, where we apply them, and some practice examples of them. So in this case, we're going to wrap up and see what it means specifically to be a zero of a polynomial. So we're talking about these x-intercepts and what are all the possible meanings of this. So we'll call any number r. So if r is the number that we find, little lowercase r. So consequences of r being a zero of f of x. So f of x is just the function. So we're going to look through the 4 different things that this means. So the first thing is that if we plug r into the function, we have a remainder of 0. So that means that the function must equal 0. That must be true. Second, r, the term. So if we go r to the left or right and then up or down 0, that must be an x-intercept on the graph. So if we're looking at this on the graph, it must touch the x-axis at this point. Second, for the third one, x minus r is a factor of f of x, so the opposite of r. So if r is the actual 0, the opposite of r in this case is the factor. And then lastly, if we do our f of x, our function, and we divide it by x minus r, this has a remainder of 0. So if we divide the function by its factor, it must have a remainder of 0. So these are all 4 things that this means. So this is the big picture. So the reason why we're solving for these individual terms is because we're looking for zeros. We're looking for places on a graph. We're looking for factors. All of those things are the reason of why we're doing this work. So for this one, they tell us x plus 1 is a factor. So that's good news because basically it's telling us that, okay, we know that this one works. When we plug it in, it should divide out evenly. And we're trying to find our other zeros and also enter this into its factored form. So the first thing that we should do is maybe we can just double check, make sure x plus 1 actually is a factor. So remember, if we're dealing with x plus 1, the actual intercept is x equals -1. So in this case, our r, that term that we're looking for, that intercept, is -1. So if we look at it on our function here, we should see here -1 plus 7 minus 6. And that does, in fact, give us an answer of 0. So that works. So the factor is x plus 1. The intercept is x is equal to -1. So just a key differentiating point there between the factor and the intercept. The signs are different. So let's find the other zeros of this and write it in factored form. So step 1, we will take our first number and our last number and write out their factors. Remember, it's all plus or minus. Step 2, we'll take our last term and divide it by our first term. So we will take plus or minus 6 divided by 1. We'll do plus or minus 3 divided by 1. We'll take plus or minus 2 divided by 1 and plus or minus 1 divided by 1. I think I said 1 and then wrote 2. So we're all dividing by 1 because the only thing that we can divide by here is just that one term right there. So answers that we get that are possible are 6 and -6, 3 and -3, 2 and -2, and 1 and -1. So what we're going to do here is we're just going to look for all of our other possible factors by seeing where we have our remainder of 0. So we'll start off by just plugging in some numbers. So we know, they've already told us this, x plus 1 is a factor. So x being equal to -1, that works for us here. So if we take a look here, basically that's how we solved for the first one. Is we plugged it in, we found that we had a remainder of 0. So let's keep trying. We'll just go one by one and we'll find all of our remainders. So we'll try plugging in 1 this time. So if we do 1, it would be 1 to the third minus 7 times 1 minus 6. So 1 minus 7 minus 6, which gets us, I believe that should be -12. So we don't like 1. Let's move on to 2. 2 to the third minus 7 times 2 minus 6. Okay. So it looks like here we end up with, is that -12 again? So again, it doesn't look good. We'll keep going. -2 this time. -2 to the third minus 7 times -2 minus 6. Okay. Now we have -8, positive 14 minus 6. And it looks like that should give us 0. So I'll highlight -2 in green. Looks like we found a second factor. We got to keep going because it wants to find the other zeros. So let's see here. We'll do 3. So 3 to the third minus 7 times 3. That's convenient. 2 in a row. So positive 3. That works. Keep going to -3. And again, all this is just calculator math, things that you can plug in. You just have to be really careful with those negatives when you're plugging in. All right, so this one here, it looks like we get, is that -12? So -3 does not work. Okay, so we've done all the 1s, all the 2s, all the 3s. All right, down to 6. All right, so 6 to the third power, that's 216. I'm just going to check on the calculator real quick. positive 6 doesn't work, and then looks like we ran out of room here, so we'll do negative 6 next. I'll use my zoom feature to give me more space. So negative 6 to the third minus 7 times negative 6 minus 6. All right, so let's see. This one comes out to negative 180, so it also does not work. All right, so our three terms that we have here that work are 3, negative 2, and negative 1. So those are the actual R values. So if we are looking to write it in factored form, we would have to not write down the R values. We'd have to do the opposite of them. So if we have R is 3, R is negative 2, and R is negative 1, our factored form, so all of these right here are our intercepts. The factored form, though, is the opposite of those intercepts. So x minus 3, x plus 2, and then x plus 1. And putting all of those three things together, that is what's going to give us our original function there. So all of this equals x cubed minus 7x minus 6. So there is our fully factored out answer. And that is the power of what we were just working on, is that we're able to take larger terms and basically fully factor them down into all of their different zeros, into all of their different terms. So that's what we're going to be working on today, is moving a step forward from identifying intercepts and to identifying some of the factors that we see here. So practice questions are coming up now. As always, if you have questions, let us know. But as always, thanks for watching. Thanks for taking notes, and we're here to help.